All right, how's everybody doing? We good? All right, you enjoying the conference so far? All right, good. I will try not to destroy your expectations. All right. So this is getting your nerd on with Microsoft's cloud data services, right? So who here, you're developers, right? All developers, good. SQL people. More hands should go up. More hands should go, yeah. Don't lie to me. Okay, I'll be a SQL person. All right, good. All right, so we're going to talk about the cloud data services, Windows Azure SQL database. And you've, we've been here, what, I don't know, 4 or 5 hours. We've heard some insight into Windows Azure SQL database and some storage. We're going to dive deep into some of these. I am a SQL guy. I have been working with SQL Server for a long time, but we're going to talk the cloud data services from Microsoft. Quick introduction. So my name is Scott Klein. I'm out of Redmond. There's my blog, my email address, and my Twitter handle. So if there's anything you guys want to talk about more after, please email me, contact me. Happy to talk about that. We good? So what we're going to talk about today is, as we learned a whole new, what do they call it, new word today? What did he call it? Passier, yes, thank you. So we're going to talk some about Microsoft's more passier services. Okay, that's there. We are not going to talk about any of Microsoft's IaaSier services. We'll leave that. But we may get into some of Microsoft's SaaSier services. Right? And we learned from Magnus today that there is a new one. What was it? Backend as a service, so BaaS, right? So but since we're talking data services, these are some of our BaaSier data services. Huh? BaaS, hey, play on words. All right. Look, here's the agenda. Right? Microsoft's got a whole set of PaaS data services. We're going to focus on Windows Azure SQL Database. We're going to talk about Azure Storage, specifically Azure Tables. We may get, if you guys want to talk about blobs, you can talk about blobs. And we'll get into some best practices and considerations, right? So those of you who worked with Windows Azure SQL Database? Okay, most of you. All right, good. We're not going to spend a lot of time there because it's SQL, but there's some things that we need to talk about. And then Azure Table Storage people, worked with that? Okay, good. So I know you guys are developers. When I asked developers, most of you raised your hand. But so I'm a data guy, and you need to understand that data drives the world. I don't care what kind of application you write. It could be an award-winning application. But if there's no data behind it, it's a waste of time. True statement? So data drives, okay? So we're going to talk about these data services. Now, having said that, there's something important I learned today from data, okay? Who knows what today is? Today is a really important date worldwide. Anybody know what day it is? Thank you. Say that louder. Today is International Speak Like a Pirate Day. Right? This is important information, people. This, yeah. So when I ask a question, your response is, "Arr," and give me the answer. Arr. Okay? That's your answer. That's right, matey. Right, so this is right. This is important information. I wouldn't have found this except through a data feed, right? So data drives everything. So you know your answer. This is this is important. So you know what you're doing today. Arr. Okay. Like quick tangent. Like you wanted to know that, right? All right. Okay, let's keep going. So we're going to talk about these things. Come on. There we go. All right, so let's begin with Windows Azure SQL Database. And the reason we're talking about this is as developers, you guys need to know, hey, how do I work with these services? Yes, we've worked with SQL Server before. We know how to connect, things like that. But there are certain things that we're basically saying, hey, take your data and put it in the cloud. Well, as a developer, what does that mean for me? Right? So I know you're application developer, any SQL developers here? Just one? Come on. Don't be, it's not a sin. Raise your hand. It's okay. Right, okay, yeah. So we're going to talk about how do you work with these, and why you should be concerned about these, right? And get basically best practices and let's get performance and things like that. Talk about these kind of things, right? So it kind of helps. Let's talk about Windows Azure SQL Database. Let's look at the architecture around, because it kind of just really quick, just as since you're connecting to the cloud, what does that mean for you, right? So, and on-prem, there's the box, right? There's our SQL Server box. We can touch it, smell it, feel it, right? We can name it, give it instance names like Batman, Superman, Ratbert, Dilbert. You've all done that. Don't lie to me, right? You can give it things, but you can't do that in the cloud, right? This is, hey, here's you spin up a server. It gives you a name. It's a TDS endpoint. We can't name it we can't name it Ratbert and Dilbert. So let's take a quick look at the architecture, and really there's really nothing different, almost the same architecture except for this services layer. So all the languages, if you've used, most of you raise your hand, so you know this, right? All the languages you use today, .NET, PHP, Java, ODBC, all those great stuff still work, right? You've got a bunch of MVPs over here that can test that, yep, still works, okay? The only difference here is this, we now have this services layer. So on-prem, we're not making this direct connection to the box. We have this services layer, and the services layer is responsible for provisioning and billing and metering and connection routing, right? You guys familiar with this? Okay, good. We won't spend any time. It's provisioning. When I create a database, which physical server in the back end is the least busy, gives me the performance to create my database, and the true replica, right? Things like that. Billing and metering, and then connection routing. I'm not making a connection to the physical box. It's routing my connection to where my database is, okay? And there's the SQL database fabric. We got to point that out because its job is, right now this is Windows Azure SQL database is shared environment, right? So when I create a database, it may be very well go on the same server as your database. So this SQL database fabric's his job is to make sure that we all play nice, because I don't want I know you don't want me to rob critical resources from you, right? And I don't want you robbing critical resources from me. So make sure that we all play nice, okay? That's the architecture. So as a developer, there's certain things that we have to consider as we're developing for Windows Azure SQL Database. Okay. Now remember and we'll actually get to scalability in a second. But there's a statement now that many years ago, when you're working with SQL Server, right, you could do a lot of bad stuff. And right, bad code, and from a SQL side of things, and the server would hide that. We'll actually get to that, but you can't do that anymore. Okay, so there's certain things we have to think about, right? As a developer, here's some things you have to think about, right? So idle connections, long running transactions, failover events, throttling, connection pooling, and retry. Which one of you guys talked about retry? That's yes, Magnus talked about retry. Absolutely critical when you're dealing with cloud-based computing. Retry, absolutely critical. Your best friend is that transient fault handling application block. One line of code to define your retry policy. How many times you retry and the wait between retries. One line of code. Okay, that is your best friend, right? Idle connections, right? How long will Windows Azure SQL Database will disconnect your connection after it's been idle? How long? Anybody know? 30 minutes. Thank you. 30 minutes, right? Because it wants to free that up and make it available for somebody else, right? It's always thinking about performance. So 30 minutes. If you've got an idle connection, so please use connection pooling. Point blank, right? Use connection pooling. Long-running transactions. Windows Azure SQL Database will kill a long-running transaction after how many hours? Any non-MVP know the answer? Anybody know? No, keep going. 24 hours. If you have a transaction running for 24 hours, we need to talk. Okay? That's not good. Right? That's not good. So, right, it'll kill that stuff, okay? Let's talk, so connection pooling, retry, we talked about that. Let's talk about throttling really quick. What's throttling? Anybody know what throttling is? What will Windows Azure SQL Database do as far as throttling? Anybody know? So there's soft throttling and hard throttling.
When there's too many calls per second, it will just stop taking care of it.
Yeah, pretty close. He's saying when there's too many calls per second, it'll start scaling. Yeah, so so if you're really hammering the resources on the box, right, it'll start scaling you back. It may soft throttling are things like, hey, it may limit the number of connections you can make. It may prevent, say, hey, prevent you from connecting from a certain amount of time, things like that, right? It's not going to do anything harsh, right? To hard throttling. Anybody know what hard throttling is? Hard throttling is it's going to go and go, dude, you're doing something really bad, so we're going to take care of you ourselves, right? Which means it may kill all your connections and prevent you from connecting for like 30 seconds or something like that, right? Because it needs to free up those resources. Now, I don't want to scare anybody away because you really got to be you really have to be doing something really bad to get throttled, even soft throttled, but it's there, right? And in conjunction with the connection pooling, the retry logic, right? You can, with the transient fault handling application block in your retry logic, you'll get an error back if you're throttled. And what you do is in your try catch, just interrogate the error coming back, right? And there's documentation all over MSDN that says, here's how you do that. What's the error number? It'll tell you if you're soft throttle or hard throttle, and what's the ramification of being throttled. Done. Okay? Is this important information to you as a developer? Yeah. Oh, absolutely it is, right? Because you don't want that error coming back to the user going, what the, what is this, right? So this is as a developer, you got to be considering going, okay, am I being throttled? Because you're dealing with now latency going across the wire, things like that. So there's things you need as a developer need to consider as you're writing your applications, and they're this. So use connection pooling, you build in retry logic. And did you guys know that there's actually and I can show you this if we have time. Did you know that there is a retry? You don't even need. Has anybody ever tried to build in retry logic without using the enterprise library? Yeah? How hard was it? Yeah, yes. I lost hair over that, right? Did you guys know that there is I think it's called, I can pull it up, that there's a SQL retry built in right into ADO.NET? You don't even need the enterprise library. What the enterprise library allows you to do is define the retry policy and give you a much more detailed granular control over how your retry is done. But there's actually in ADO.NET a SQL retry automatically, right? Don't even need the enterprise library, but I would highly recommend the enterprise library. Okay, any questions so far? We good? Excellent, let's go on. Okay, remember I said earlier that kind of what's old is new, right? So how many of you, and don't be afraid to raise your hand, how many of you have hid bad code by throwing more memory and CPU at your SQL box? Come on, every hand should go up. Yeah, because you could hide that stuff really well, okay? Because it's memories, it used to be that you couldn't do that, right? Many years ago when memory and CPU were really expensive, there's certain things you had to think about, okay? Now, with memory and CPU being really extremely ridiculously cheap, you can hide bad code by just throwing memory and CPU at your application. I don't need to rewrite that. I'm good, right? You can't, right? You can't do that anymore in the cloud because you don't have control over the resources on that box. Right? So long-running transactions, writing bad queries, things like that, right? You need to be thinking about how you write, and we'll see if we have time. If we have time, we'll actually get to that, right? So along with that is scalability. How do you scale? You want your users to have the same, right? You take your database, you throw a bunch of hardware at your problem, right? So now the application's running really good, right? How do you do that in the cloud, right? You can't throw more hardware and CPU. So how do you scale in the cloud? Anybody know the difference between scale up and scale out? MVPs. Shh. Anybody know the difference between scale up and scale out? What's scale up? Yeah, this is where you're hiding the problem, right? Let me just throw more stuff at it, right? Scale out says, let me distribute my load across multiple nodes. Take my database and partition that database across multiple independent nodes, okay? And Mike over here did a great explanation about kind of the consequences of that, right? So, like let's say, for example, you've just created the greatest thing since sliced bread, right? Some widget, gadget, myget, something like that. I'm throwing you a bone. Where are you? There you are, right? So the greatest thing since, what was that? No, come on. Dude, you make a horrible pirate. That's true. I did throw you a bone. We are having way too much fun here. Yeah, but it's good. Keep it up. That's right. And a skull with it. There you go. All right. Where were we? All right. So let's say you just created the greatest application since sliced bread, right? You want to sell that on-prem. How do you determine the hardware that you need to sell that, right? So as Mike explained, you have this huge upfront cost, right? So you buy all this hardware and you hope that that it sells well and makes you a lot of money, but two, that you have all this hardware sufficient enough to support the load and that all these orders are going to come, right? So what happens if you open the pipes and, sure enough, man, you're selling this thing like crazy, but you don't have enough load, right? How do you add hardware? How do you add a hardware really quick, right? So then all the machines come to their knees because of the load, right? So then, but then after, let's say, because it's Mother's Day or some great holiday that it sells great, but then after the holiday's done, all your sales come crashing. There's no sales because that's not hot anymore, or there's no holiday, and so now you have all this underutilized hardware. So this was what Mike was explaining. You have this under-provisioning and over-provisioning, right? You have all this either overutilized hardware or all this underutilized hardware. So how do you scale? This is where the cloud scalability comes in. We've talked about this all day. Scale up and scale down based on demand, and just pay for those resources you use. What's that? Scale out. Did I say up? Sorry, scale out, right? Yeah, out, right? So, and just pay for what you use. So how do you do that? How do you do that in the cloud? Okay, so there's several ways we can do that, right? Everybody's heard of SQL Federation? You guys have heard that? We're actually not going to talk about that, okay? Because there are some challenges with scale, okay? What are they? Without looking at the slide. Okay, and there's even things on here that aren't on here, right? So how do you define the tenant? How do you know what to partition on? Is it customer ID? Is it product ID? Is it sales ID, sales date? Right? How do you know what to partition on? Is it a range partitioning? Is it point partitioning? How do you do splits, merges, joins? Right? One of the challenges with SQL Federation works great in certain scenarios, but what's some of the limitations of SQL Federation? It does not support identity. Okay, so and the reason it doesn't support identity is because one of the issues was that if you scale out and you start partitioning and you're all doing identities, somewhere down the line, two tables in two different partitions may start generating the same ID, right? What happens if you merge? Okay, so how do you solve that? How do you solve that? Okay, so things like that. How do you move? How do you start taking one tenant out and move that to another? There's things like that you have to think about. Okay, and then the transient nature of connectivity, right? As you're starting to move your shards around, you just start moving your connections around, right? That's not a big deal, but there's certain things you have to think about in the terms of cloud development. Now, as a developer, the question is, if you're scaling, should you as a developer have to worry about where customer ID 10 is? Now, the right answer is no. Just going to help you out here, right? No, okay? Because, yeah, thank you, no. So at any given time, one of the basic principles of federation or scalability is that I, as a developer, should never have to worry about, even if I'm partitioning real time, dynamic partitioning, if I'm in the middle of a partition, my application should know where customer ID 10 is at any given time and should route me there. Bam. Okay. So how do we do this? And how do we do this? Okay. So demo time. No. Ooh. All right. You guys are awesome. Arr. Okay, so after regardless of whether the demo fails or succeed, you got to tell, that was awesome. Okay. Wait, great demo. Thank you very much. No, I'm kidding. Okay. Look, we're here to have fun. Okay. All right. All right. Okay, so what I'm going to do is, so I've got this. Scale out data. Now, one of the principles is that well, I got 40 minutes. We could we could do this all day. All right. Arr. All right. So one of the principles of scalability is being able to partition, right? So we've got shard, not shred. You shred XML. This is a shard. A shard is an independent node. Okay. Shard. Shard. Who started that anyway? I didn't. Shard. That's next Jack Sparrow movie. Arr. What? If I'm rated bad, it's because of you. Because of you guys. All right. So, yeah. All right. So what we want to understand is that how do we partition? And what are the principles and concepts around database partitioning? All right. From an application standpoint, it's, same thing. Has anybody ever, just like retry pause, has anybody ever tried to create, kind of a cache map or partition in their application before? No, because it's hard. That is really, really, really hard. So, one of the things around, SQL Federation is that it's great in certain scenarios, but, you've got a root database, right? And then you have all your shards. And so the root database in a large scale environment kind of becomes a bottleneck, right? Because all your connections kind of come into that root database. And so if you have hundreds, even thousands of partitions and users just hitting that, where's your bottleneck? Well, it's that root database, right? But then at the same time, how do you split and merge? Okay, so we got to kind of alleviate some of those issues. So what we've been working with, what we've been trying to work on, is kind of a shard map caching strategy, where from the application standpoint, I can generate a shard map from my application. Doesn't matter what I'm doing, I'm good, right? From the application standpoint, I don't care where my data is. I just want to split and I just want to be able to create my shards and manage those shards. And so this is kind of a really early implementation of something that we've just been kind of throwing out and putting on paper, and let's see if we can get this to work. Okay? You guys interested in this? Okay. It's yay, buddy. Yay. All right. All right. So I'm not going to go very deep, right? Because I still got a half an hour and we still have tables to talk about, right? But I want to get you guys thinking. Okay. So here we have, and I'm going to run this. And this is really just, I'm going to kind of walk you through this, and we'll just kind of go a little bit, just to get you thinking about. And you guys, if you're interested in this, you want to take this a little further, we can have discussions after. Okay? So, let's go. Come on, emulator. Emulator. See, there you go. You got to scare it. Okay. So here we have just a very simple, this is not an award-winning UI. Very simple UI, right? But what we're doing is that we have what's called, here's our settings, okay? And this is just, right? Some global settings. This is nothing to be concerned about, but just some global settings and what's my connection information. I have over here, I have a server defined. So where am I deploying my shard? I'm going to do this locally just for speed and, right, so I don't run into latency. Because again, this same principle, even though we're talking about cloud scalability, why can't that apply to on-prem as well, right? Even better. Okay, so I've got my server defined, and then I go to configurations. We have what's called a workload group, right? A workload group is things like, this is what says it manages my shards, right? So a workload group says I have X amount of shards, and here I've said, okay, I'm going to do a shard type of range. I want right now 4 shards. I want a max of 10 shards. Okay, these are shards meaning independent databases. Max tenants per shard is 100, and I can change that. Min shard size, things like that, right? Max shard size in megabytes. And then what I have down here at the bottom, I don't know if you guys can see that. Let me scroll down. Right, I have this, can you guys see that? Woo! DACPAC path, right? So to make the deployment of my databases easier, I'm going to say, hey, use this kind of template. You guys familiar with DACPACs? You guys know what a DACPAC is, SQL people? Yeah, MVP hands go up. Yeah, DACPAC. So in SQL Server 2012 and 2008, you had what's called a DACPAC. A DACPAC is like a little artifact. It just contains the schema of your database. Make sense? What's great about this DAC pack is that you can, it's like an MSI, you can actually take that DAC pack and push it out and create multiple other databases off that DAC pack, right? Almost double-click go, almost, right? In 2012, they new versioned that and what's called, just from a naming perspective, a backpack, right? Man, this is some thought went into that one. But backpack, but it's the same artifact, but includes data, okay? It's even better. Right? But we're going to use a DAC pack because we have no data there, so we just use a simple DAC pack, right? So what I can do here is I'm going to go in, this is basically I'm saying, all right, I want to go into here and go into and create a shard map based on this all the information we just saw. That server, how many shards you're going to create, things like that, okay? So I'm going to go edit, okay? Go back to shard map and say calculate shard map based on that information they just pulled from our workload group. So if I go back to shard map now, there's my shard map. Okay, so if we look at this really quick, it says, right, it's going to create 4 databases for me, right? And there's a low range to high range, right, for 4 databases. So what happens is now when I insert data, I don't have to go make a physical connection to this database. It's going to know based on my ID and things like that, oh, put that data here. Or when I query, oh, just pull that query from here. Right? And one of the challenges around SQL Federation also was, you guys know what fan-out query is? Right? I've got data maybe in 10 databases, but how do I query data from all 10 at the same time? Right? So what I need to do is be able to do a fan-out query. Is execute a query simultaneously across all 10 databases or shards, bring that data back, aggregate that data, and give me my data back. Okay, things like that. All right, let's keep going. So let me save that. And let me go back to shard map, and what I want to do is deploy this now to my servers. So I'm going to edit. And if the demo gods favor me, I do deploy to servers. Oh, you know what I did? I messed up because I didn't name it SLK. All right, you know what? Can I come back to that? All right. So in essence, and I apologize, I should have named it because everything is SLK from the configuration standpoint. I totally forgot about that. What this does is it then goes out. I will do this demo again if you guys want to see it. Well, it'll go out and then create 4 databases, those 4 databases for me, right? And then at that point, let me just run this again really quick. Man, I didn't even think about that when I was running this. So it creates, when you say deploy to server, it actually goes and creates those 4 shards. So I have 4 databases, right? Then at that point, what I need to do is, and when this is done, go back to configuration. Come on, got a half an hour we still have to talk about. So if I were to click on, nope, not shard map. If I say publish shard map, what that publish shard map does is it says, now make this available to my application. Okay, so even though, so the first one was calculate shard map, right? So it says generate the shard map so I know what it looks like. Publish that shard map, or create my databases or my shards based on that shard map, and then make that available. Now you could do this a different way. This is, you can just kind of walk you through and help you understand kind of the process and the thought process of what we were doing, right? So publish my shard map, now make that available to the application. So, because at that point, what I could do is go over to a query window and just say insert into, boom, done, right? Query. Let me go back, right? So if I were to go over to queries under this query window, right? I could easily. So I should have named that instead of WG1. I should have named it SLK. That was the issue I had, right? My workload group. That was the issue. Right, but now what I can do is execute a query and just say select star from, and it'd pull from the give it an ID. So I basically, if I say here, I say type in an ID, right, and it'll pull that record from the right shard. Or I would do something like insert into table values, right, whatever. I don't have to, at that point, I don't have to specify what shard to go to because the shard map knows where that ID would go and puts it in the right shard. Okay, makes sense? Okay, so I need to move on. If we have time, I will demo this again. Okay, we good? All right, I do need to move on. But this is a cool demo, and if we have time, and even after this, if you guys want to see it out or whatever, I'm happy to demo this at the end. All right, let's move on. I feel bad. I meant to, totally meant to, didn't mean for that to fail. But we'll fix it. All right. So any questions about what we've talked about so far? All right. Tables. Now, Martin just talked kind of briefly about tables, but let's talk architecture about tables. The difference between here from the architectures in Windows Azure SQL Database, it doesn't do automatic partitioning, automatic sharding, right? That's kind of the downside. You're responsible for partitioning. But in Windows Azure Storage, it will partition for you, right? You don't have to worry about that. So you can just be hammering Windows Azure Storage, and it will go, you know what? I need to take this one partition over to this other server because to get better performance, not only for that partition, but to free up some resources on this other server. So it will do that for you. So you've got a request coming in, and it sends that request and distributes that request over to the front-end servers. Those front-end servers can talk to any and all partition servers under the, right? So if you've got partitions and data sprawled across multiple servers, it will any front-end server can talk to any of the partition server to get that data automatically. This is awesome because now you're talking about thousands and thousands and thousands and thousands of transactions a second, right? Inserts and reads, right? Things you don't have to think about. You're just doing inserts and updates to Windows Azure Table Storage, right? So, but what does that mean for you as a developer? So let's talk about that. So the storage concepts for Azure Table. You guys Azure Table people, you've got an account, you've got a table, and every table can have entities. Who's entity framework people here? Three of you? All right, so this might make sense, hopefully. So you've got an account, a table can have entities. Entities are just, we'll call them records, right? The difference between, and Martin talked about this a little bit, the difference between Windows Azure Tables and Windows Azure SQL Database is what? One's relational, one is not, right? Please do not take your Windows, your relational database and put it into a non-relational storage. Why? Well, okay, so it should look, a lot of it's listed here, right? So in Windows Azure Tables, there's no relationships. You can't have primary keys and foreign keys. There's not. You get sort of one index on a Windows Azure table, but that's through your partition key and row key, right? So one's relational and one's not, but you can still do inserts, updates, deletes. You can still write to it just like you can Windows Azure SQL Database table, right? You can still use link queries and any framework queries against the Windows Azure, against a table, right? But it is not. They are different. They are very different. And as a developer, you need to kind of your homework assignment is to understand and kind of when would I use a relational table or relational database versus when would I use a Windows Azure storage table storage, right? One's relational, one is not. Okay, and there's a reason you decide as a developer or as a company, you decide to put your data in a relational database. You put it there. You need that relational integrity. You need that RI, right? You lose that when you go to a non-relate, a kind of a NoSQL scenario. Okay, even though from a cost perspective you're going, yeah, this is much cheaper. Yeah, this is apples and oranges. Okay, make sense? Okay. Yeah, yeah, thank you. Someone's still excellent. All right, so, but one of the great things about Windows Azure Storage is that there's no fixed schema. Okay, what does that mean for you? What's that? I get awesome flexibility, right? I can define a class. I can put whatever in here, and the reason being is because I'm not dealing with rows and columns. I'm dealing with key value pair here. So I can key value pair if you take like a what is that network traffic sniffer? There's several of them. I just drew a blank. Huh? Yeah, Wireshark or things like that. If you were to look at the payload coming back and forth, it's just key value pair, right? So because of that, I could have no fixed schema. So I could have, in essence, right? So, excuse me, my date, I can have different types of dates in Windows Azure tables. I can have one row have two rows have 3 columns and one row have 4 columns, right? I get that flexibility, right? This is awesome because I just get that more granular control. I get that flexibility on Windows Azure tables, okay? From a querying perspective, and Martin talked about this, and it was great points. Your job is, just don't blindly throw data into Windows Azure tables. Okay, he talked about things like what I want to get to is partition keys and row keys. Right, a partition key can be anything. Right, your row key can be anything, but your row key must be unique per partition key. Right. So, pop quiz, would you use a identity column from your SQL table as a partition key? No. don't do that. Yeah. How do you say what's the opposite R? Right? No, yeah. So yeah, you don't want to do that. But you can certainly do that as your row key, because that's unique per partition key, right? So when you're querying, you want to be able to basically say, be smart about how you define what your partition key is and what your row key is, right? Because you could have as a partition key, you may end up with, a million rows in a partition, but when you start querying that stuff, that's a lot of data you're pulling back, because you're saying where partition key equals, you could be pulling back a million rows, right? And that takes a while because you're going back and getting 1,000 at a time, right? So that could take a while. You have to think about that. Right, and I don't think this number is that right. I think that's the 500 transactions per second. I think we're up to 2,000 or 5,000 transactions per second now, or something like that. It's pretty high. So I should have updated that. Sorry. So I mean, it's Windows Azure Storage. You're talking about I think it's up to 5,000 transactions per second. That's a lot. Would I put Twitter on Windows Azure SQL Database? Probably not. But would I put that on Windows Azure Tables? Absolutely, in a heartbeat, because it's key value pairing. It makes sense, right? And so you've got all these just records inserting and reading type of thing. This is awesome. I would put that in table storage in a heartbeat. Okay, so as you start defining what as a developer, and you're starting to how do I define and what does my tables look like? So for partition key, right, I've got kind of categories. So I've got bikes, canoes, rafts, things like that, right? I wanted to understand, how do I define these? Right, and what does my row key look like? Right, so and at that point you're saying, well, now let me, if a certain category, starts getting a lot of traffic, I can partition these out and say, all right, bikes through canoes goes in this one partition, and rafts through whatever goes in this other partition. It will automatically split those out for me. I don't have to worry about it. It's doing that live behind the scenes. Okay, this is great. Okay, makes sense. So this is automatic for you. You don't have to do anything. All right, so. Demo time. Every time I see demo time, I think of hammer time. Demo time. Dun, 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 dun. Demo time. Dun. See, he wasn't going to dance, but I danced for you. Thank you very much. But I am not quitting my day job because I'm a horrible dancer. All right. So the question is, how do you define, because we think about in terms of Windows Azure tables. Let me close this for a second. We've got this, so multi-schema. Okay, so if you're familiar with Windows Azure tables, working with Windows Azure tables is really, really, really easy. Okay, who's done it before? I think I asked this a few of you. Okay, good. So it's as simple as going and saying, all right, I'm going to define a right down here. Where's it at? I'm going to define a class, and it inherits from table entity. All right, this is standard POCO, Entity Framework people, standard POCO development. Okay, define my class. That table needs to inherit from a couple properties, partition key and row key, define things like that, right? All right, so in this example, I've got a class, but how do I, in my environment, how do I have an application say, how do I say, I want my table to have multiple, I don't care what the schema is, no fixed schema. How do I define that? Has anybody done that before? One person? Anybody know how to do that other than an MVP sitting over here? Right? It's actually not that hard. Okay? So I've got my initial, so I'm basically going to deal with shapes. In this example, I'm dealing with shapes. So I have, you saw this, I have a shape entity, right? So just a base shape. Right, X and Y positions, colors A, R, G, B, and G, right, and the shape type, whatever it is, okay? This is my base shape. But now what I want to do is say, well, I want one table to house all my shapes. So I don't want a circle table, I don't want a square table, I don't want a triangle table. I want all my shapes in one table. But they all had, but each one of those has different properties, right? So how do I define that? Well, I'm glad you asked. This is awesome. Okay. What I do is I just go in here and say I'm going to define multiple classes that inherit from my initial shape entity. Right? Yeah. Okay. So I've got a rectangle entity that's got, in addition to all the original properties, right? I've got a width and length, because that's a rectangle. You know what's sad? I actually had to look this up. It's been so long since I've been in math that I had to, what's a rectangle have? All right, so there's triangle, right? So base, altitude, area, vertex, right? There's my square entity, perimeter and area, and down there I've got a circle entity, right? So what I'm going to do here is I'm actually going to open, and someone asked, don't let me forget, someone I was talking over here asked a question about something, and I don't want to forget about that. Who was it? It was about, Mike pointed it out, and then someone was asking about Azure Data Sync, right? So someone asked me about that. You? All right, we'll actually get to that. But someone I heard earlier say that this is Sarah Brada. This Cloud Storage Studio actually got bought by Redgate. Okay, so this is a Redgate tool now, right? And someone said actually that so there's my shape table, and someone actually said that you can't write a query through this tool. Yeah, you can, right there. Select star from right there. Okay, so there it is. All right, so I have no data in here. So what I'm going to do is I'm going to fire this up. Now, I spent a lot of time on this UI. I'm very proud of it. This is an award-winning UI. Arr. Did I start it? There you go. Okay, that took me a long time. All right, so what I'm going to do is I'm going to insert each one of these, rectangle, triangle, square, and circle. Okay, and it's all going to go into the same table. And what does that look like through like Cloud Storage Studio and in your data, right? So we'll say rectangle, shape added, say triangle, shape added, square, okay, and circle. Isn't this great? This is this is awesome. Look, I'm a data guy. If you want me to write an application, you are barking up the wrong tree. Yeah. Boy, these guys, did you see how fast they agreed with that? That's pretty sad. You know me too well. All right.
You're the man who is furthest away from the UI.
Yeah, exactly. This is why my UI looks like that. Yes. All right, but here's my data. Okay. Okay, so there's my partition key, right? And there's my row key. I just use a GUID. But there's my circle. It's got radius, diameter, circumference, right? But then here's all the common properties that we saw in the initial class, okay? And then there's all the different ones there's width and length, perimeter, area, base, altitude, vertex, right? So what I have now, does this make sense? What I have now is one table that basically I have whatever shape, and when I say shape, columns, right? There's no fixed schema in this table. I could throw whatever in here, right? I could probably, if I wanted to, create another table called cats. Sorry, that's the first thing that came to my mind. Cats, inherit from that shape entity and just throw whatever in there, right? So it's no fixed schema. But the people online are just going, what the heck? Right? So no fixed schema, but it allows me to get very granular and just however I want to work with this data. Okay? Make sense? Okay. So last, I got 10 minutes left, and then we'll save some time for Q&A. All right, I've got a little demo here, so let me get rid of this. Okay. We can close that. I've got one last demo for tables, because one of the questions is, I don't need that. Right, this one, right? So kind of what I wanted, this is why I kind of, in Windows Azure SQL Database, I broke out from scalability, is, how, whenever you're dealing with, it doesn't matter if you're dealing with on-prem, doesn't matter if you're dealing with the cloud, man, we want to be able to just get the best performance out of whatever our data source is. True statement? All right. So how do we do that? And so from a Windows Azure SQL database standpoint, we do that by partitioning. Okay. And also the reason we do that is from Windows Azure SQL database side is what's the biggest database size in Windows Azure SQL database today? 150 gig. Right? Who's got databases bigger than 150 gig? Yeah, everybody, right? So, so how do you get around that limitation? Well, we do that by partitioning. And by doing that, you can actually get better performance. Instead of out of that one, we're now distributing our load across multiple databases. We can actually get better performance. And, more than likely, a cost savings, right? So, in that point, so how, one of the interesting things that I've been toying with a lot, and again, this is very kind of alpha, which is kind of things we've been playing with, is to say, how much data. So truth be told, let me take a tangent really quick. Truth be told, what I really wanted to do, and one of the demos that I really wanted to do today, I couldn't do, but I'm going to try to do it later on, was I wanted to see how much data I could slam into Windows Azure SQL Database and Azure Storage at the same time and see who, kind of what throughput I could get. And what I was going to do is this required audience participation. So whether you liked it or not, you were going to help out. Okay. And what I was going to do was I was actually going to pull up a Windows Connect, right, for the PC. And then what I had was I had a kind of a robot here that I was going to bring here and set on my desk. And then I had another robot that I was going to have in my office back in Redmond with a camera pointing at it. Okay. And this is kind of the cool thing to say, how much information can we shove through the cloud? So what I was going to do is get someone up here and do general movements, and I really feel bad I couldn't get this. And the reason I couldn't do this is because when I ordered the parts, they showed up at my house after I left on the trip. So, right? So what I was going to do is have you guys do a movement, right, and then play it back to the robot on the stage, but then show the camera back in my office in Redmond and play that same data back to that robot back on my desk in Redmond. How cool would that have been? And what does that mean? From a data standpoint, what does that mean for you as a developer? I could record something, share that data and save that data anywhere in the cloud, and then anywhere in the world play that data back to any other place, right? Anywhere, okay? So think about this from a second. One of the things that they're talking about, so think about it as I wonder if I can say this. So one of the things that they were working with is be able to say, what if I recorded movements here and had a puppet on the other end that played back what I did? I didn't have to go to the puppet. The puppet was on the other end of the line. I did my movements and the puppet moved based on what I recorded. Okay? So think about the possibilities with that. Right? So it's not just how much data can I shove through there, but because I'm using the cloud, I don't have to be where the puppet is. I don't have to be where my my endpoint, whatever is. Does that make sense? So that's kind of cool. What this does is this is kind of so it was kind of a multi-point. It was how much data can I shove through here and how fast can I get data into the system. My thing's falling off here. All right. So what I'm going to do here is I'm just going to run this. And what it's going to do is it's just going to start. So I've got, if you can see this really quick, it's a setup, right? So basically it's setting up my connection. Right, it's defining my connection limit. It's defining there's my account credentials. There's my cloud storage account. There's my table client, things like that. And if I'm getting throttled, what's my throttle policy? So I'm just setting stuff up really quick. Then I've got my parse arguments because I'm parsing in certain information from the command line, right? So the number of worker threads, the batch size that I'm shoving into Windows Azure tables. Am I inserting or update or replacing current entities? What's my payload size? What's my max buffer pool size in megabytes? And what's my timeout if timeouts, right? So these are just things I'm parsing. And then, so I'm getting all that stuff back, right? And then I'm executing. And the execute task is just saying go, right? And create multiple threads and just run current, if you can see this, run concurrent table test. And then down here it's saying do table inserts. So it is just running concurrent table tests and just slamming data into these tables. Okay? So let me run this. Okay? So let me wrap up with this. So it started 9 worker threads, and right now it's per second. So you should start seeing this number go up. So, right, 1,371. So what this is doing, this is actually going against. It's actually going across the wire. So we to the West U.S. data center, right? So this should actually start going up and up and up and up. So the transactions per second, right? So this is if we're to leave this running, this would get higher and higher and higher and higher and higher, right? And what I would really love to be able to show is that if we were to get multiple instances of these running, could we see a partition happen, right? That would be ultimate, but we didn't get to that. We're still working on that, right? But this is just, that number is just going up, right? And this, we're just slamming data into this table, right? And so if there's throttling, we handle that throttling. So what we want to do is just this kind of shows just really quick, kind of the throughput that we can get through in per second. We're already almost at 9,000 transactions a second, right? Spread across multiple worker threads. Okay, this is just going and going and going. Okay, I would love to be able to do something like this against Windows Azure SQL Database and say, okay, where's my limit on each one of these? Okay, now I will make this code available once we get it to a point where it's solid. But this kind of gives you an idea of kind of how we're thinking about it. How can we shove data through this? And as a developer, what are my limitations, and how do I handle those limitations, and how do I handle working with these cloud data services? Okay? Make sense? Okay. So we're already at 15,000 transactions a second, which is pretty cool. All right, so I'm going to leave that running a little bit, but let me wrap up. Okay, so that's just, I got 5 minutes left. So what I do want to wrap up with is one of the things that so this is Azure Server Core. There's no UI. Oh, there it is. Okay, so there's a couple things that we do back in Redmond to help you. Okay, and I don't know if you guys have heard of this, but there's a thing called Azure Office Hours. It's not the MVP one. We've done this thing where we got every, I think, Friday at 9 a.m. we have what's called Azure Office Hours. It's bankotips.com. And what we do is a live broadcast where it allows you as the community, and every show we have one of the Azure PMs on our show, and gives you the ability to ask questions, and ask them questions about anything Azure. Okay? Does that interest you? Okay? So bankotips.com/office hours. We took a hiatus during the summer. We're going to start those up here probably next month. But if you go there, if you go to bankotips.com, you'll see what shows are coming up and which Azure PM is going to be next on our show. Right? And allows you to talk directly to the PM. Okay? And then we're doing a live radio call-in show for developers, right? So what we've done is we've got a couple other VMs. And this is gonna be a live radio show where you can still call in, but it's just a radio show. Think just standard radio, but it's an internet radio show. So stay tuned for that. We're in the process of putting that up. All right. So thank you. Any questions?